Hello, welcome to Groundwork. This is a podcast from the McClanahan Corporation where we talk about key material processing topics, anywhere from agriculture to mining to material recycling. We'll discuss the best ways to process these raw materials that power the world, because if it's not grown, well, it's mined. Our topic today happens to be managing tailings for the future, how sustainability is shaping the mining industry. My name is Scott O'Brien. I'm the host of this particular podcast. My title here at McClanahan, my role is the Global Director of Mineral Processing. I've been with McClanahan for 21 years. Oh, God, no, it's 2025. Longer than that now. 24 years. I've been looking at rocks since 1976 to try to figure them out and be just a little bit smarter than they are. And after whatever that is now, 49 years, I have a pretty good respect for how smart they can actually be. With me is my compatriot from Australia, Mr. Richard Williams. I'll let him do his introduction.
Yeah, hi, Scott. My name's Richard Williams. I've been working with McClanahan, a bit over 10 years, but been in the industry, 30 plus years, perhaps not quite as long as you, Scott, I'm going to claim the junior role. But most of my focus has been in working in tailings and mine tailings and, understanding what needs to be done and how all that has changed over the last 20 or 30 years.
Just a quick note, just to be clear, in case anybody who tuned into this has no clue what tailings are, I guess we owe it to you to just give you a quick definition of it. Basically, tailings are anything after the processing, mining, and then processing to extract a valuable material out of what it is that you've mined. It's everything that's left over. So that can range from fairly large-sized pieces of rock all the way down, and very typically to very small particles of ground-up minerals and processed material. That has to be managed for quite a long time. I mean, the life cycle for a pond is basically cradle to grave in this country. So it's something that has to be paid close attention to.
I don't know what your experience in the US has been, Scott, but certainly for us here in Australia, the tailings previously was considered pretty much the last end of the process, something got a bit forgotten about. Nobody invested too much money in, doesn't generate any value. But of course now there's an increasing social expectation for the whole mining process, and a part of that is how we responsibly deal with, manage, store, reprocess, reuse tailings, all of that sort of stuff.
Oh yeah, I mean we've had these recent incidents down in South America, and some tailing dams failures up in Canada.
But it was maybe 8-9 years ago. I'm not sure. That was a not a very pretty sight, but fortunately it was no fatalities. But
Yes.
That's drawn attention of the whole industry. That was one of the instances that's drawn attention of the industry to question, can we do this better?
Yeah. I know my experience in the States has been not so much in mining because of the size of our aggregates industry. We have a lot of manufacturers of aggregates for construction. And the idea there obviously is to size and wash materials so that they're appropriate for building materials, but you're left over with a lot of clays. And man, when I first started in this business, you just sent the stuff out to a big old pond and hope for the best. Then people started to figure out that, there's actually some value to that real estate. They've got reserves underneath of that pond.
Yeah, look, I'd agree entirely, Scott. That's certainly what I've seen. But I think in the mining space, as the operations have got bigger and bigger, I think the aggregate industry talks about a pond. Now, the mining industry talks about a tailing storage facility or a dam, and some of these are enormous. Unless
Massive.
You've been out and seen some of them. These are several kilometers long, several miles, perhaps in your language, long, couple of kilometers wide. They're hundreds of meters deep, and what that does is that contains an enormous volume of water, of liquor, and that poses an environmental risk that I think the mining companies in particular are now recognizing that it's a risk on their balance sheet. Suddenly, it's got an economic kind of implication, and so can we reduce that risk? Can we do that better, more efficiently? More acceptably for the environment and the people.
Yeah, I mean, I think of the work we did at Goro. I mean, it's not uncommon to be able to get out onto Google Earth and take a look down at some of these countries, these mining areas, and these tailing storage facilities are quite large, unbelievably large.
And I think that certainly when we were doing that work, it was owned by a Brazilian company, and they were influenced by those terrible disasters that happened in Brazil.
Right.
But just recently has the court case been concluded, and the economic impact of those disasters has in a way been quantified. I'm not sure that it's entirely. You can debate about whether it's a valid outcome, but the courts have awarded and said that those big major mining companies have to pay billions of dollars to rehabilitate, to recompense the local community for those issues. So I think that's drawn the whole mining industry's attention to the fact that you can't just, as you were saying, you can't just send it out to a pond out the back and forget about it.
So a lot of those decisions are made based on how the company feels that they can best manage their tailings prior to development of the site, right? So they may say, "Look, we need to filter these tails." Obviously, then the stages they have to look at are thickening, filtration, and then how to stack the materials, or at least move them away from the filter press. Why somebody would choose just to simply go to a high rate thickener and then straight to a tailings storage facility with the slurry, those are all economic decisions that they have to look at up front. Today, you could probably argue that once you have a deposit identified and you go to the bank to say, "Hey, let's develop this," one of the first questions they're going to ask you is not what's the grade, but what are you going to do with the tailings?
Yeah, precisely, Scott. It's all about the life cycle impact of being able to get that permit, and that permit involves how you're going to not just mine the site, but how you're going to rehabilitate it, how you're going to return it back to as it was. And so here in Western Australia, the mining companies have to pay a fee to the government for the area that they're going to use for their mining lease, including the tailings. So the bigger the area that they need to store material, the bigger the fee that they have to put up to get those permits. I think another important factor that dials into this, it's not just the cost and the permitting. There's an increasing recognition that water is a valuable resource.
Right.
So how and there's competing requirements for water. Here in my part of the world, you might have mine sites sitting alongside agricultural enterprises, and they both want the water, and they there's only a limited finite resource. So that the more efficiently that you can use that water, the better you can recover it. The more times you can reuse it will have influence on their ability to get permits, their ability to access the water, perhaps the amount of throughput they can process, because they're limited by the water permitting that they're getting. So not the tailings deposition, but the water source. Now, yeah. I guess you've probably seen the same thing in the frac sand industry, doing similar things like that, right?
Yeah, well, certainly. I mean, these days in the States, the frac sand industry has moved to different parts of the country where they've been utilizing finer sands. They're into some deposits that are relatively free of clays, but boy, when it was back in the heyday up in the upper Midwest, Wisconsin, Minnesota area. Yeah, there was a lot of plants that went in. The local authorities said, look, the only way we're going to let you get a permit is to put in thickener and ultimately a filter press to stack the clays, because they were rife with clays in that area. Beautiful sand, but a lot of clays as well.
Yeah, and what sort of surprises me in that industry, Scott, is seeing, the tailings plant can be about the same size as the processing plant. I don't think it's quite the same scale or concept in mining, but the tailings plant is becoming a bigger and bigger part of the whole infrastructure.
Yeah, and I what I've seen in my lifetime is an appreciation for the tailing side, where it used to be, and probably still is to some degree, it's not the exciting part of the job. There's nothing shiny out there, hey, where's the gold out here, It's say, hey man, this is a pile of mud. You say, yeah, that is a lot of mud. And it was always looked at as, wow, this is just where I'm going to lose my money as opposed to make my money on the other side. But in fact, if you don't do it, you're not going to get any money at all. You just won't be around.
That's the exact critical thing. You have to do it to be able to have a license to operate. If you don't do it, you just simply won't be able to operate. So, but hey, interested in your comment about mud. That last PACE conference in Canada, and I turned up at the border, and the customs guy says to me, the immigration guy, "What are you here to do?" "Oh, I'm here to talk about mud." And he goes, "Yeah, really? People get together to talk about mud?" I said, "Sure do."
But let's not forget that the demand for what comes out of the ground is people. I don't know. I don't want to say it's underestimated. It's not even considered in a lot of people's lives. They just wander through life thinking that mining. That's an old technology. What is that? Do we still mine? It just blows me away. How many people still think like that.
If you want a new mobile phone every 3 years, you've got to have the copper to go in it. You've got to have the gold, the silver. You've got to have all those rare earth minerals.
Do you like drinking your wine out of a glass? Yeah, sure I do. So,
yep. Yeah, but I think that's it's sort of a significant change in Australia I can speak of, where the mining companies recognise that they need to attract and retain bright, enthusiastic young people. And if the industry is perceived as being old and stale, and bad for the environment and all of that kind of stuff, then they'll struggle to get those people excited and involved. Not too many people get excited by mud, Scott. Only a few of us,
Yeah, well, I'm getting help.
So, Scott, here at McClanahan, we've got quite a focus on doing more for tailings, right? Because it's an expanding industry. It's the customers are going to need to address these issues.
Yeah. I mean, obviously we've got a full thickener range, high rate, high density paste thickeners. Basically, each one of those unique in so much as the types of muds that they can produce as far as yield stress. Filter presses for the dry stacking. I mean, some of the other things that people are doing stacking with might be belt filter presses or centrifuges, that sort of thing. I don't know if we could really consider that dry stacking, but it does create quite a high yield stress material.
Yeah, what do you think about the size of filter press? Because to filter, to use a pressure filter to process a large volume of a huge mine, if you took to those big Chilean copper mines, they're pushing through thousands and thousands of tons an hour. And so there's a demand for a bigger and bigger filter press. I mean, I've always wondered if there's a practical limit to that, or whether, companies will just keep developing bigger and bigger equipment.
Just when you think, you see, well, they're never going to make anything bigger than that, and then along comes the next largest one. Yeah, I don't know. I mean, I don't know how the costs stack up from a capital standpoint. Maybe from a long-term operation standpoint, it makes a lot of sense. Certainly, the fewer of those, well, I don't know. You could argue I've got fewer machines. That's an easier setup for disposal, maybe collection point, but if you're processing that much material, you're going to have some serious conveyor work to do just to get that material out in the field and give it its final resting place.
As you mentioned before, the tailings plant will become increasingly complicated. You'll need pumps and mixers and instrumentation, automation, all of that requirements to be able to put through a large volume of material.
Yeah, I am surprised some of these inquiries we do get, Richard, what they are trying to achieve. So the interest is certainly there, right from the smallest operator up through the largest. And maybe we should recognize the smallest operators are usually the guys that you think would never have the money to do it. But I guess just because of their...
Yeah. If you remember that paper that we put out a few years ago talking about, filtering tailings in cost competitive industries, you first think that they can't afford it, but we get back to that question of they can't afford not to do it because they won't have an operation or they don't have space or they need the area or so. When you look at it holistically, there's a lot more benefits. People can get kind of a little bit focused on the capital costs, and they're not insignificant. But it's a case of like, what's the alternative?
Yeah, and in those industries, I know that a number of them have found beneficial use for the filter cakes. They've actually sold them, whereas they going into the project. The idea was, okay, we're just going to stack this back up and use it as fill for further past mining areas. Lo and behold, people come along and want to use it for all sorts of things. And a lot of it, I think, not only depends on the quality, maybe how impermeable it might be, or a size distribution or something like that. But does it contain something that's can be used to improve farmland?
Oh, look, I think there's a lot of people looking at that, saying, how can we recycle and reuse?
Yeah.
I'm not sure I've seen any good examples where that's been done a lot. You're right. There is certainly some. Maybe if you've got those high clays, you can use those as a clay liner. I think in some cases. Mm-hmm. I think that's the nirvana, is to be able to somehow recycle and reuse that equipment. And so there's a lot of people that are looking for that. The filter press is a technology that's I think, well, in my view, has really come along in the last 10 years, maybe.
Yeah.
I think prior to that, easily. they were renowned as being, perhaps not very reliable. You'd work on 80% utilization. Would that be the sort of number?
A lot of issues with any sort of automation. A lot of them were just simply manual presses and whatnot. Bringing them into the world of mining, of course, it was something new. They've been around since God left Chicago, as far as pressing grapes and whatnot.
Yeah, but if you look at the big filter press now for tailings compared to those
insane.
Little, those olive oil presses or something, it's kind of like, it's just not the same thing, right?
No,
the amount of automation, the valves, the porting, the fact that the whole thing runs totally unattended is, it's a sophisticated piece of equipment.
Yeah, they're impressive to watch,
I talk about tailings, or I guess the industry talk about tailings. We tend to think of slurry. Now, I guess it doesn't necessarily have to be slurry, but the majority of processing methods involve, using water, so that you end up with a slurry as the outcome.
Right.
There's a little bit of a trend, or at least people are investigating how much dry processing they can do, so that way they're creating a dry waste that is a bit easier to handle. I'm not sure that's really solved yet, but I think that's one direction that people are going to, because it gets away from that huge liquor volume storage issue that we talked about before. That's risky.
Right. And hence why I think a lot of people are going for dry stacking of tailings. So whereas a thickener is a big tank that basically settles this material out and thickens that material for deposit.
Yeah, correct. I mean, almost every mining operation will have a thickener on the tailings that's taking the material from, 10% solids. It depends on the processing, to 30, 40, 50% solids. But there's still a lot of remaining liquor in that storage. And yeah, I guess the next evolution, as you say, is to filter that to a dry stack as the industry, as the terminology is becoming commonly used.
And also, just to give a shout out to our friends who are in the paste business. We go to these paste conferences all the time, and there's a lot of researchers around the world that try to study the best way to come up with creating a very stable slurry that doesn't necessarily liberate any more water, but just kind of sits and spreads out over an area to get dried by the sun or whatever. This is, with filters, going a step further.
Yeah, well, look, you're absolutely right, Scott. But the most appropriate method of dewatering, managing the tailings, depends on lots of factors. There's the climate, there's the topography, there's the material, there's the mineralogy, there's the particle size, there's the geotech, there's so it's never one size fits all, is it? At least that would be my opinion.
No, I think that absolutely. I mean, where do I find my tailings plant? It's not like, aisle 6 halfway down on the left-hand side. There you go. There's a lot of research that goes into the best way to handle whatever material it is that you're processing.
Well, the right solution, is I think we've said this many times. It's not one size fits all. In some cases, a regular tailings dam will be the right approach. But increasingly, more and more companies are finding that getting better water reduce and smaller footprint from the tailings has a value. The equipment that you need to dewater the tailings depends very much on the particle size that tailings is determined at, right? And if you've got a very fine particle size distribution, you have to use a lot of force. You have to use a big hammer, right? You've got to push the stuff out there.
Yeah.
So you're going to need high pressure filter press. Typically, it would be the common way to do that. But I think that what I've seen and I've heard people talk about is it's perhaps sacrilegious to the mining engineers or something. But would you concede grade and recovery? Would you concede recovery by processing a more coarse particle so that you have less of a tailings management issue?
Possibly so. The ability to be able to if you have a coarse liberating particle or mineral, right now the reason you might make it finer than it already is, past that size of liberation, is simply that so you could take it down to more conventional processing. But there are newer technologies out there that, such as coarse particle flotation, it certainly could help out that situation.
Seems to be grabbing hold of people's attention here in Australia.
Yeah,
is to for copper gold applications, perhaps to grind more coarsely, use slightly different technology to be able to recover those particles, but then it gives you a more easily manageable tailings. Perhaps you'll use a vacuum filter, or maybe a dewatering screen, or cyclone stacking rather than the filter press.
Whole lot less capital and a lot less energy.
Yeah. So again, it's horses for courses, isn't it?
Man.
It's not that every situation's a thickener and a filter press. Maybe it's a cyclone, maybe it's a separator, maybe it's a dewatering screen, and each project kind of goes through that evaluation stage, don't they, to decide what's the best combination for them.
Absolutely. Do your homework.
The filter press is a well proven bit of equipment, and whereby you're using the pressure of the pump to push water out of the cake. One of the things that I always kind of object to with some of our team even is talking about these to being a press. Because when you look at them, it's like a machine that opens and shuts. And people often have the impression that the closing of the press actually somehow squeezes the cake.
No doubt.
And,
yep.
and I just always feel that you're using the word press only reinforces that idea. I mean, I like the term pressure filter because you're filtering the material, but the pressure is created by that feed pump that is pushing the material into a confined cavity and pushing out all of the residual water and creating a dry cake. I mean, I guess that's the ultimate requirement, is the dry cake, because that enables the material to be handled well, enables it to be stacked, able to be conveyed, pushed around, stuck up in a pile. So that's the key on the filter press.
Yeah, and when it's put that way, I mean, I always, for whatever demented reason, I go right to the imagery that I used to see of how they would get trains loaded on Tokyo platforms. Back in the day, they'd have these official train pushers, and they would just keep cramming people in. You get them inside the doors.
Yeah, so I guess what you're saying is the analogy is what we're trying to do is trying to cram in more slurry into that confined space. Just as long as they're not losing people out the other side of the train, I suppose would be the.
Yeah, that would be bad for ridership. So yeah, right after the filter press completes its cycle or completes its filtering process, you've got to get rid of those cakes, and they drop out, and as the plates open up, they're collected and either dropped straight down, right? They'll get removed by maybe a front end loader or and dump trucks, or they'll go into a conveyor system to take them to their final resting place. But in any case, the fact is we've gotten a lot of the water out of there. It's not completely dry, so people say dry stack tailings. Yeah, it's not dry. There's moisture associated with it. Certainly not as much as there would be with a slurry. But that gets put in place, and it forms a very stable slope. Can form a very stable slope given all the other conditions are there.
I think it might be important to just articulate or the difference between dry stack and filtered tailings, because you can dry stack. You can thin layer deposit a paste to create a dry stack, right? Now that's different to filtered tailings. So I think the industry is going to, more dewatering because you get the value of the water and higher solids content, but it's not always filtered tailings is the answer. It's fairly obvious, probably, Scott, but the fact that you're only stacking the solids, the footprint of your tailings storage area is much, much smaller.
Oh, absolutely.
So you've saved on that, and you've done away with all that risk of impounding all of that huge volume of water. And I think,
right,
risk management for all of these big mining companies is increasingly, what they're trying to quantify and justify that. So by getting away from all of that volume of water that's stored there, just changes the perception that people have of the operators.
Yeah, and we should also just mention quick that it's not really it's not fail safe. There have been instances where we have seen movement of filtered tailings. The cool thing about it is they don't go very far. They kind of act like we hope them to, which is they stop. So the pore pressure can build up on the bottom of that pile and be like a brick on a short roller skate ride. So fortunately they've not been catastrophic slides or anything like that, just kind of shifting around. And I know also that there's a lot of research that goes into how they might even mitigate those sorts of occurrences as well.
Yeah, I think that's an important point, Scott, to point out that what we can do in the process, what McClanahan can do, is we're experts in equipment design and creating the most efficient equipment to do the dewatering part. But the whole tailings management process involves that whole geotech part of the managing the storage facility. That's really not our expertise, and there's other people who have a lot more skills and a lot more competence in that area than us.
Yes, those are businesses that are staffed by plenty of experts in other fields.
But I think, Scott, it's important then to recognise, the contribution that we make is just
absolutely.
It's part of the whole scenario. We're not. We're not a company that in fact I don't know any company that would provide the whole process, right from taking the slurry to depositing in an area and having the 20-year responsibility for that deposit area. That is something that will always, in my view, remain with the operator, with the owner.
Yes, absolutely, and we provide an integral part of that whole process, but.
Scott, as we talked about many times, it's not always one solution that fits all. And dewatering tailings is a continuum. You can go from high rate thickeners to high density thickeners to paste thickeners to filter tailings. And at each stage, you're removing more and more of the water, and you're creating a more, how would you say, like a more cohesive product, so that if you're and in my mind, the difference you're creating that by the driving force that you're putting into it. So for the thickeners, for a high rate thickener, you've got a relatively low compression height in the thickener, so you don't have as much force, so you don't push out as much water. Paste thickener, of course, you're having much higher sidewall, so that creates a much
deeper bed,
more compression. So in a way, it's a higher force. So you're that next level up of dewatering, but you're still not creating a cake. To create the cake, you've generally got to use some sort of filter, and you've got to have a more forceful mechanism to push out the water. But each of those technologies, come at a different price point and different range of equipment, and different ultimate deposition, methodology. So for instance, if you use a paste thickener and you're creating a toothpaste type material, you can probably pump that with a positive displacement pump. I don't know if you found the same. So so you have the opportunity to use a pipeline and a pump. But if you're creating a filter cake, then you're into conveyors and or trucks, right?
Right.
So it's kind of like a whole conflicting or matrix of variables to figure out what's the best for each site. We've talked about. You can have lots of different equipment to create a tailings plant. And there's often a discussion, I find, particularly if you've got a coarse tailings, whether there's value in cycloning out the coarse, dewatering that via, say, a dewatering screen, and then reducing the volume of material going to the higher energy filter press.
Yeah.
Now, have you found that's an efficient way of addressing tailings?
Well, we have, Richard. That, in fact, is when we get samples into the lab, a lot of times we'll look for that sort of ratio of coarser material along with the fines to see if we get any appreciable increase in the filtration rate, simply because it's not all clay. And we have found that in a number of instances, you can get really nice filtration rates. Now, people say, well, do I need more filter presses now to handle that additional amount of material? And of course, that's the thing that we certainly look at, and we have found occasion where, leave that little bit of coarse material in there. You don't necessarily have to increase your filter press size. You can typically increase the filter cake thickness, which drops the price even further, because now you don't, instead of 150 plates, you have 75 plates in there.
So again, whether it's best to filter the whole tailings or whether you're better to cyclone out the coarse and manage that separately to the fines, it's a bit hard to be generic on that. Would you say you need to really test for that?
Yeah, I would say so, because the other thing is, when you're sending fines to your filter press, that obviously is going to increase wear. Perhaps you may not get as much life cycle out of cloth.
So in some situations, Scott, it could be advantageous to have a small, I think what we'd call a ultrafines recovery plant or something like that, with a cyclone, a dewatering screen for managing the coarse, and then the cyclone overflow, the fines perhaps going to the filter.
Correct.
And in that way, I guess we're reducing the mass going to the filter, but the challenge is it's all the fine stuff, right? Which is difficult to filter.
And it really depends on what is that fine stuff. Is that fine stuff all clay minerals? Is it all bentonite? Bentonite rock or montmorillonite clay, the smectites, the horrible smectites. We always recommend testing for filtration. Testing goes a long way as to coming up with the appropriate solution for any customer.
Yeah, I think more information is always good. The testing is only as good as the sample that we get to test.
Oh yeah,
true. So we need to be reminding the people that provide us samples with, it's really important to try and make that as representative as you can. I don't, I guess, I'm not out there collecting that sample, but I feel that some diligence in terms of thinking about, what material you might end up having to process, and maybe even a range is always helpful.
Yeah. It's good to understand. I mean, particularly, look, for smaller operations, your sites are usually they go with it. They're also small. So the extent of the deposit that you're looking at is also a little bit more definable, perhaps, than what you might have in a large-scale mining operation, where you really need to understand the geology and what types of materials you're bound to get into. So there you go. It's still more about educating yourself on the deposit.
I guess this is your bent towards rocks coming out. You got to know what you're starting with. You got to know what the rocks are, where they came from, what's involved.
Mineral processing starts in the pit, man.
Oh, that's right. Absolutely, yes. I'd just like to kind of conclude a little bit more about the future for mining, because I think there's a lot of discussion about the electrification and green energy and where all that's going, which is all terrific. But to do that requires a lot of metals, a lot of copper, particularly very strong in the electric components, but also lithium batteries or vanadium or graphite or any of those battery minerals, all of that rare earth stuff. Now, the demand for all of that is going to be growing and significantly huge. So I don't know whether the general population, as Scott was alluding to, recognizes that this is to implement a more green energy environment needs a lot of metals to do that.
So with that, thanks for listening to Groundwork, the McClanahan podcast. Please be sure to follow us on social media for updates and more content, or if you'd just like to reach out to any one of us for any questions you might have, go for it. And we'll see you next time.